Hello and welcome to the video lecture on data normalization. This topic tends to be fairly confusing to most people that are first confronted with it. Let me start off by saying that this is more than likely not something that you have to deal with in your database project, in the project that you're doing for your database. Typically, when you follow the methodologies that we have been using as far as the problem statement, setting up your entities, looking at checking out the attributes, doing the ER diagrams, transforming to relations, using those methodologies to perform the database design typically means that you are in at least, that your database at that point is in at least third normal form. Okay, and we'll get there. Third normal form is typically sufficient, and we'll talk about that again in a second. So this is primarily a topic that I want students to realize that this is something that you probably only have to deal with when you're creating a database from a pre-existing sets of data, right? Or you're dealing with an old database management system that has to be converted. In other words, you may go into some companies and find out that they've been keeping track of all of their data on 100 different Excel files, and that's very common in the finance industry. And for people that are not database savvy, they are getting a lot of use out of Microsoft Excel, which is a very, very powerful software system. And then you come in as a consultant and you say, well, now we have to convert the way you've been storing your data currently to a database management system. So in that case, you may run into situations where you have to normalize their data. So these are techniques that you will use to help avoid unnecessary duplication of data, right? So we're talking about efficiency. So we want to get more and more efficient as we go along here. So we don't want to be storing information on disk in multiple locations. One, it's a waste of disk space normally, and duplicated data means that if we need to make a change, we have to make a change in multiple places. What this process typically requires is that you decompose relations, so that you realize that there are relations that are storing duplicated data and so forth, and typically that means you have a larger number of smaller, well-structured relations. So let's take a look at what we mean by a well-structured relation. Again, minimal data redundancy is the goal, and allows the user to insert, delete, and update information, right? So that's the whole idea of creating a database management system, is to allow the user to modify and maintain data, right? Without causing data inconsistencies. You don't want somebody changing data and then having your database in an inconsistent state. So what are we talking about? So there are anomalies that can occur. So we have insertion anomalies, which means if I add in a new row, due to the structure of the table or the entity or the relation, the insertion of new data means that I have to create duplicate data. We're going to talk about examples of that. Just kind of hold that in mind. Then we have deletion anomalies, which means if I delete a row, I'm actually losing information that I could use or that I might need, right? So we're going to talk about that as well. And then we're also talking about modification anomalies, where if I want to change information, I have to change it in multiple places because I have data duplication. General rule of thumb, tables should not pertain to more than one entity type. So let's take a look at an example. So here we've got an example of employee. As you can see, Margaret Simpson has been duplicated. We've got an underline under emp ID, which means it should be the primary key. But as you know from primary keys need to be unique. So in this case, we have non-unique, that emp ID can't be a primary key, right? And as you can see, if say Margaret Simpson got married and decided she wanted to change her last name, I would need to change that in 2 rows instead of 1 row. If Alan decided to change, was moved from the accounting department to another department, well, Alan's not a good example, but Chris Lucero, if he moved from information systems to the accounting department, I would have to change 2 records. If Susan was given a raise, I would have to change 2 records. And the course title, right? So if I wanted to do something like SPSS was no longer known as SPSS, and SPSS was now SPXS, for instance, I would need to find all of the instances of SPSS and change them, and you can see they're in different, they're on multiple records. So, a couple of questions. Is this actually a relation? Well, yes. They're unique rows and no multi-valued attributes. We're going to talk about that in the next video when I talk about what's known as the first normal form, which defines something as a relation. So yes, this is technically a relation. But what's the primary key? It's certainly not emp ID by itself. It's not emp ID and name. That's not going to work. So in this case, the primary key would be the combination of emp ID and course title. And that really doesn't even work in our world because Lorenzo Davis doesn't have a course title. So that means an aspect of the primary key is going to be null or blank, which is really not allowed in database management systems. So let's take a look at possible anomalies. So I can't enter a new employee without having the employee take a class, although when we look at Lorenzo, that's technically not the case. If I remove employee 140, right, so who's 140? That's Alan Beaton. So if I remove Alan Beaton, the problem is I also lose the information about the existence of the tax ACC class, right, because he's the only one associated with that. So since this table is keeping track of courses and employees, if I get rid of Alan Beaton, employee 140, I also lose the course title tax ACC, right? So that's the deletion. The insertion anomaly, again, I have to add more information than I want to. And then the modification anomaly, if I want to give a salary increase to an employee, I have to update multiple records, and we talked about that already. Now, why does this happen? Because really, we've got two themes or 2 entity types in this one relation, and that's why I said you're probably not dealing with this in your project, because in your project you followed a very logical design. So when we talk about a very logical design and we go through the process the correct way, your entities should have unique themes to them. So that is the end of my video lecture on the introduction to data normalization. We're going to talk about functional dependencies and the actual normal forms in another video.